For over 30 years, Messersmith customers like this school have cut their fuel bills by at least 50%. How is this? By burning wood chips instead of oil or gas.
The Vermont School District had issued a report based on the studies and findings from their current wood chip plants. And in those findings, a critical number that they had passed on to us was that for every 1 ton of wood chips burned, they were saving 61 gallons of fuel oil. That savings alone is incredible when you look at the fact that our client, the school district, is paying roughly $37 per ton of chips versus $3 and roughly 60 cents per gallon of fuel oil.
Each Messersmith industrial biomass boiler system is designed to meet your specific needs. This location houses the boiler system in its own building. Here is the boiler system as seen through the open door of the boiler room. Wood chips are burned in the combustor. Most of the heat from this combustion is transferred to water that moves through the boiler. This hot water circulates through your building to heat it. Fuel may be stored at grade or below, as in this example. A truck easily delivers wood chips to the storage bin. This one can hold 3 tractor trailer loads or 80 tons of chips. An ample supply of wood chips allows a flexible delivery schedule. On the other side of the blue wall, 2 traveling augers pull wood chips out of the storage bin. Most Messersmith systems have only 1 traveling auger. Right now this auger is stationary, but it will move along the beam as needed to find chips. Now, the auger is supported at this end only. Inside the bin, the other end is free. The belt conveyors and traveling augers run intermittently, as needed, to deliver wood chips to the boiler room. Notice how the belt is textured. This enables it to carry wood chips even when they are frozen. A sensor, to ensure proper operation, monitors each belt conveyor. This view from the boiler room shows the end of the belt conveyor, where it drops fuel into a metering bin. An exclusive Messersmith chip screen automatically rejects oversized fuel. Oversized pieces can otherwise cause problems and downtime. A photoelectric sensor monitors the level of wood chips in the metering bin. It is not bothered by dust. When the wood chips get below the level of the sensor, the conveyors and traveling augers turn on to refill the metering bin. A variable speed motor drives the metering augers inside these blue troughs. The augers turn, metering fuel to match the heat load on the boiler. The chips are then dropped into the stoker augers. Inside the black troughs, the stoker augers carry fuel into the combustor. They turn fast enough to maintain a fire break between the metering augers and the combustor. Each stoker auger has a heat sensor on it. This is part of the fire suppression system. If there is any rise in temperature, then a small stream of water is automatically sprayed into the trough. If the temperature becomes too high in the metering bin, this sprinkler will also spray water.
From the early on stages of a project, teamwork is critical to the success of that project. From day one when I contacted Messersmith about this application, they were involved from that phone call forward. The early stages involvements included different ideas and concepts. If they felt that what I was proposing they had a better solution to, they stepped up and passed on that solution. That involvement was very critical to the success of this project.
These fans provide preheated under-fire air to the combustor through the grates. Dampers on the fans are automatically controlled according to the firing rate of the boiler. To ensure complete combustion, overfire fans supply additional preheated air. The correct combination of wood chips and air in a well-engineered system results in a controlled, efficient burn. Final combustion takes place in a secondary combustion chamber inside the base of the boiler. With the doors open to the boiler, you can see the fire tubes. The hot gases that pass through these tubes heat the water in the boiler, which then heats your building. The most you will ever see coming out of the stack is a water vapor plume. Emissions from a Messersmith system are very low. For instance, carbon monoxide measured in the stack is less than 100 parts per million. What's more, the temperature in the combustor runs at about 2,000 degrees Fahrenheit, while the stack temperature runs at only 340 degrees. The drop in temperature is the result of efficient heat transfer in the boiler system.
Now we have the facility fully operational. Emissions are incredibly low, lower than expectations of DEC and EPA. Appears to be running very well. There's a few minor bugs, but they're being addressed, and we're almost there where we have no problems at all at this point. Maintenance is about a half hour a day, maybe to an hour a day. That's including cleaning, sweeping the facility. Very happy with it.
This boiler is a hot water system. The operator control station that you are looking at here shows that the set point of the water is 180 degrees Fahrenheit. This screen shows that the temperature in the boiler is currently 157 degrees. This is low because the boiler system is in a startup mode. You'll notice that the temperature is increasing at a rate of 0.2 degrees a minute. This is just one screen of many that relays data on the operation of the boiler system.
The computer is really the brains to the whole system. As the boiler gets closer to the set point, it modulates down by adding in less fuel as it gets closer to the set point of the boiler. Let's say it's at 180 degrees, the set point is, and as it creeps its way up, it'll start backing down the fuel rate, the air mixture, the overfire air, and the underfire. It keeps backing them down. So pretty soon we're down to a low fire. And as the demand of that gets greater at the school, it'll start dropping the water temperature. So the boiler or the computer will respond to that and start increasing the fuel rate, the air mixture, and overfire, underfire. And that is tuned so we can get a very low emissions rate off of that.
Air from this compressor is fed to this manifold attached to the side of the boiler. Periodically, compressed air is injected into the fire tubes. This keeps particulate from coating them on the inside, which would reduce heat transfer efficiency. The stack gas cleaning equipment consists of an induced fan and a multicyclone. The induced fan provides the draft on the boiler. The multicyclone spins the gas and removes the very fine fly ash, which then collects in the barrel below.
Our customers demand every day that our products come from sustainably managed forests. In the forests of this North Country area where we sit today is a great example. Some of the highest concentrations of independently certified forest management systems are right here, both publicly owned and privately owned. In the New York State where we're at today, nearly 2 times as much woody biomass is grown out in our forests in New York State than is harvested and dies every year from natural mortality. So there is a growth of this industry.
The wood chip boiler itself was worked faultlessly. It was just actually a really wonderful design. Where it was clean, it was spotless. There was no smell. It was an absolutely wonderful facility. We found out there was very little ash produced. There was almost no maintenance. It just was exactly what we were looking for.